everyone! So I just solved a problem and I found it so amazing that I just had to make a video about it. And the problem is this right here. We want to minimize this monstrosity of an expression in two variables x and y, where x and y are elements of the positive reals. And believe it or not, there exists a way to minimize this expression without any tools from like multivariable calculus or something. In fact, there exists a pretty elegant solution for this problem. And yes, I came up with the solution, which means it is natural for me to call my own solutions elegant, simply to boost my self-esteem. Never mind, okay? So, we want to minimize an expression in two variables. Two variables is not good. We like one variable because then we can set the derivative to be equal to 0 and solve from there. So we want to somehow convert this expression of two variables into an expression in one variable. And to do that, first, it might be a great idea to simplify this thing a lot. So let's start with the denominator, shall we? So we observe that x squared times y plus x, our denominator, is exactly equal to x times xy plus 1, factoring out in x. So it might be a good idea to find as many factors of xy plus 1 as possible in the numerator to then cancel them out down there in the denominator. So let's see. Let's take a look at our numerator, as I was about to say, x squared y squared minus 2x squared y plus 2x squared plus 2xy minus 2x plus 1. And now, let us decompose this term. I will do this in red. We will decompose this term into x times y plus x times y, because then we can factor these two terms together. Well, we can group these two terms together rather, because they will make an xy plus 1 term. I don't know why. Never mind. So we'll have xy plus 1, and then plus, there's a plane going by, sorry for that, x squared y squared minus 2x squared y plus 2x squared plus an xy there, and then minus 2x. And then I would like to factor these two terms together, the x squared y squared and the xy, because once we factor out an xy, we get our desired x times y plus 1. So we will get xy plus 1 plus xy times xy plus 1 minus 2x squared y plus 2x squared, and then minus 2x. And now, what can we do? Well, I would like to write the coefficient of 1 in front of the xy plus 1, and here is why. If we factor out an xy plus 1, we get xy plus 1. So in other words, this right here is exactly xy plus 1 quantity squared. So this is xy plus 1 quantity squared minus 2x squared y plus 2x squared minus 2x. Good. And now, there is another xy plus 1 that we can find in this expression, and let me do this in green. We'll factor these two terms together, because once we factor out a negative 2x, we get again our xy plus 1 that we desire. Therefore, we will have xy plus 1 whole thing squared, and then minus 2x times xy plus 1 plus 2x squared. And now we can substitute these two expressions into our expression that we want to minimize. Therefore, our original expression, x squared y squared minus 2x squared y plus 2x squared plus 2xy minus 2x plus 1 all over x squared y squared plus x shall be equal to, well, this expression, xy plus 1 squared minus 2x times xy plus 1 all, well, I forgot, plus 2x squared all over x times xy plus 1. And now we can cancel some stuff out. Here, one of the xy plus 1 terms in the numerator will cancel out with this xy plus 1, leaving us with xy plus 1 all over x. Here, the x times xy plus 1 terms will cancel, leaving simply negative 2. And here, the x in the denominator will cancel with one of the x's in the numerator, leaving us with 2x over xy plus 1. And now, I would like to introduce a substitution in this expression. So we will let some u be equal to xy plus 1 over y, which means du will be equal to, just kidding, we aren't doing any iteration on this one. So why did I introduce this substitution? Well, this whole expression will be equal to u right there, minus 2 plus 2 times 1 over u, because this is u, take the reciprocal, we get exactly, wait, there is an s in the right here, not a 1. If we take the reciprocal of this, we get x times xy plus 1, which is exactly the expression we have here, but multiplied by 2, so we have 2 over u. And now, as I said earlier, we have now transformed this expression in 2 variables into this expression in 1 variable. And we can easily minimize this expression, so we will let this expression be equal to f of u, and now we can just take the derivative. So f prime of u will be, derivative of u is just 1, derivative of negative 2 is 0, and derivative of 2 over u is negative 2 over u squared. And now we will set the derivative equal to 0. And now this is pretty simple. Add 2 over u squared to both sides, we get 1 equals 2 over u squared. Multiply both sides by u squared, we get u squared is equal to 2. Take the square root on both sides, we get u is equal plus or minus the square root of 2. And now, we wanted to minimize this expression over the positive real, which means this is a positive real, the numerator is a positive real, since x and y are positive reals. Denominator is a positive real, therefore u will be a positive real. Therefore, we have to reject the negative range, leaving us with simply square root of 2. And just for fun, let's check that this is indeed a minimum by taking the second derivative at square root of 2. So we get f double prime of u is equal to derivative of 1 is 0, and we get minus 2 times derivative of u to the minus 2 is negative 2 over u cubed. The minus signs cancel out, leaving us with 4 over u cubed. Plug in square root of 2 into this, we get 4 over 2 square root of 2, which is 2 over square root of 2, which is square root of 2, which is larger than 0. Therefore, the function is indeed at a minimum at u is equal to the square root of 2. Therefore, the minimum value, which we'll call f minimum, is equal to square root of 2 times square root of 2 here, minus 2 plus 2 over the square root of 2. 2 over the square root of 2 is just square root of 2. Add this with the square root of 2 we'll already have. We'll have 2 square root of 2 minus 2. Whew. That was pretty much nice, as I said, because that's why I made this video in the first place, because I just solved this problem and thought it was nice, and therefore I chose to do a video. So this is your video. Thank you guys for watching this video. Don't forget to like, share, and subscribe. I'll see you in the next video. Bye.